So welcome everyone to Innovate QA Meetup. I'm seeing some familiar faces. I'm also seeing some new folks. So welcome. If this is your first time, welcome to our meetups. We are the community of professionals who care about software quality in delivery. So if you are a quality professional or leader or care about quality, you're in the right place. So I wanted to show you the pictures from some of our previous events and meetups. This is the picture from our last conference back in June in Seattle. We had 170 people. It was a really great event. And by the way, we just announced the dates for our conference next year, 2026 in June again, June 4 and 5 in Seattle. So please join us. The tickets will go on sale soon. And I also wanted to tell you guys about a few other meetups that are happening. And with the events and the conference coming up, we are looking for speakers and volunteers. We're, of course, looking for sponsors all the time. So if any of you know the speakers or want to volunteer for any of the events, please let me know. And I will mention the two other events that are going to be in San Francisco, actually. One event is on December 10th. It's going to be QA and AI, a holiday social. We have two amazing speakers, and we also have some holiday games for you guys to play. So it will be a fun event. You don't want to miss that if you're in Bay Area. And there is a Battle of AI Test Tools event that we're planning on January 30th. It's a full day event. It's going to be fun. You will get to play with AI test tools, and then you'll get to compete for prizes testing applications using AI test tools. So the announcement for this is going to go out in December, but keep an eye on it. And yeah, subscribe to the channel so you guys don't miss any of the future events. So that's all I've got to say. And now I want to introduce our speaker. I met Michael at the PNSQC conference in Portland just last month. And he told me that he's working on a model-based testing. And I was like, well, why don't you share with us what you're working on and what is that? Because I personally haven't used much of the model-based testing in my career. So I'm really curious to hear from Michael on and learn from him. So Michael, tell us a little bit more about yourself, and then the floor is yours. We'll go with the 35-minute presentation and then 15-minute Q&A at the end.
Okay, thank you. So happy to be here. Excited coming to you from the East Coast where it's already cold and also cloudy. So model-based testing is an interesting approach to QA, basically where we put the software specification at the center, basically, that idea. So instead of chasing scenarios, basically we spend more time understanding what the application should do and how to test that. So we're going to look today on model-based testing, basically, which is a QA paradigm that's been around for a while, but it's actually a great fit for our accelerated AI future. Okay, a bit about myself. So I've been in software engineering for about 25, almost 30 years at this point. I've done a lot of work in manufacturing and all kind of like places where airline control systems, or place where quality is critical. And so I learned to value proper software and proper software that behaves, as intended without any bugs. Other than that, I spent some time at Harvard doing data science tools, which is again, a bug in a data science tool can end a researcher's career. So they like their quality there. And at some point, I decided to kind of like go back to academia and found this idea of formal methods, which is the idea where we define proper application behavior and then kind of like impose it on the system, making sure that its system actually behaves properly. Yeah, I'm currently CTO and co-founder of Provengo, a company that does model-based software engineering tools. We do more than just testing, but we also have a lot of testing. But this talk is more about, the PhD thing where I kind of like trying to make you interested in this approach, which is, again, different and I think holds a great promise for QA currently. Other than that, I make bread and the kids eat it normally, and if they don't, then the dog does. So it's a win-win anyway. Okay, so what we're going to talk about today, basically look at how QA is done now, a bit, which I assume you all know. Look at what the idea of model-based testing is, and then see how it works in practice and what it can, where it can be applied, where it should not be applied, because it's not going to solve all the world problems. And then if you're interested, there are a few links you can see. I mean, again, not just us. This idea has been floating around for a while, and there's a lot of places you can, interested people can go. If there's any questions or anything, please. Oh, thank you. So I'm kind of like monitoring the chat, but you can also raise your hand or something. And I'm sure that
Yeah.
Tiana will.
Yeah, Michael, I'll help you with the questions. If I see any
Okay,
questions
great.
in chat, I'll bring them up. And feel free to raise your hand if you have a question.
Okay, great. So let's talk about what we currently have, right? So QA is supposed to answer the question, right? Is the software feature ready for release, or how ready it is, right? Maybe we can say so it's not complete, but you're safe enough releasing it and then patching it later a bit, right? So that's our role. This is what we want to know as people in charge of software being released. But what our tools give us is not that. It gives us basically did all tests pass, right? We have all these test scenarios and they're great. But what does it mean that they all pass, right? So we have these specifications, right? How software as it should work. And then we manually plus some help with the AI tools, create test scenarios. And there's always the question if, suppose all test scenarios pass, does it mean that application is ready? Did we test all combinations or all important combinations? Did we do like risk-based stuff? Did we do everything, just the fact that the test suite passed, does it mean that the application is ready? And it obviously doesn't mean that. I mean, there's a lot of work and a lot of thinking that goes into making the test suite comprehensive and correct and updated. But because our tools just talk about scenarios, what we spend a lot of time doing, unfortunately, is basically babysitting the scenarios, right? Just creating all the scenarios, making sure they're updated, and dealing with maintenance, which is known as like the automation silent killer, right? Because this just breaks all the time. And we get into agility issues because whenever there's a change, all the test scenarios we have become legacy code that we need to update. And this is, I think, maybe the biggest, right, the biggest pain that when change happens, then everything has to go. But it was good enough, I think, for most of the time because at the end of the day, software didn't move that fast, right? So developers were writing, but they were not writing fast enough, and we could still keep up just by manually dealing with test scenarios. However, this is software development on Gen AI today. It's moving way faster. But as you can see here, it kind of like lost steering, not to mention brakes, right? So it's like we get feature to production much faster and less accurate. And actually, software quality deteriorates, and that this is an issue. Ideally, we could just apply the same thing on our software as well, right? On test scenarios and just get more scenarios. But the issue is it doesn't really work that way, right? Because we can get more scenarios, but the main question of what does it mean, right? Are we ready? Is not there yet, because we need to, the AI just doesn't really understand all the business logic and all the background and everything. It can generate tests that looks very good. But when you get close enough to it and kind of like look at what happens, and what they really are testing, what is the test suite covers, it's not really there. And this is actually becoming a phenomenon, not just with QA, but in general. This work slop thing where AI creates something that looks good, but it's not actually good because it doesn't have domain understanding, is actually slowly becoming an issue outside of QA as well. So what does model-based testing does? The idea is this, right? Main question is the application behaving properly? So let's give a computer definition of properly, and then let the computer just automate the rest of the work. So we start with the same thing, right? We start with the requirements, but instead of going all the way to test scenarios, we end up with a model which is a deterministic model. Okay, so this is not like a, I don't know, Claude Sonnet 5.3 or whatever. This is a deterministic model that we know exactly how it's behaving. That's not to say we're not going to use AI. We are. Of course, we'll use AI in generating the model. We'll use AI later, but the core QA thing is deterministic, and we know exactly what's happening. Once we have the model, again, this is a computer actionable model, we can just generate the tests automatically. So we automate a lot of the work here, but the nice thing is because the actual test scenario, test suite generation is automated, you can also generate a lot of them, right? Because it doesn't really cost us a lot to generate. It takes about, I don't know, a few seconds to generate a test suite once you have the model properly installed. So basically, if you have a hunch, I think when users apply coupons before checkout and something bad happens, you can just generate a test suite that covers this and allows you to check this very fast. So the idea is basically we teach a model, we teach the computer how to create test scenarios, and then we have this kind of automatic test scenario generation. Which is fun, but then you end up with too many test scenarios. But just because we create them doesn't mean we need to run them. We can basically store them somewhere and store them with all the metadata, because this is computer generated, right? We can have all the metadata, everything is properly tagged and everything. And so when we decide to create a test suite, what we do, we just select the proper test scenarios and then execute them as a suite. So this is the basic idea, right? Automate, explain to the computer, or basically define in a computer actionable way how an application should behave, derive test scenarios and test suites out of this description, and then we get a much more agile and faster way of creating a test suite. And also, we don't have to babysit the scenarios, because what happens is if we have a change, then the change effect, or the ripple effect, only goes up to the model. Okay, it's not that if a change happens, we need to work, obviously, right? We need to work, but the work we do is proportional to the change. If there's a small change, we do a small change to the model. If it's a big change, we do a big change to the model. But as far as the test suite and test scenarios, we just delete them away and generate new ones. Okay, so the actual test scenarios become kind of like compiled code in Java or C or stuff like that. It's a lot of work to do that, but it's all automated. Hmm. Sorry. Um, okay, so this is that's the basic idea of how things go. And immediately you can see that we become much more agile, um, much more lean in the sense of, if a change happens, we basically work as we do the same amount of work as the rest of the team, right? The developers have to work basically based on how much changes does. Product does the same, and now also QA can work based on the size of the change rather than the amount of scenarios we have. But there are actually some extras here because the model is something that's computer actionable and can be analyzed and do stuff like that. We can actually use the model to visualize and validate and verify the requirements, which is something that sounds weird, but we'll have an example for this. So it would still sound weird, but you'll know that it's possible. And the idea is that we basically can take the requirements and visualize them, validate them against other stakeholders, and actually formally verify them against all kind of regulations or company policies. And so we can QA the requirements even before there's any implementation. It's basically the ultimate shift left, if you will, going from just being generally reactive role of QA somewhere towards the end of the software development lifecycle to actually pushing it to working with product people. Okay, so this is the basic idea. Any questions so far?
I'm still, maybe the rest of the people know, but I'm still trying to understand what exactly a model is.
Okay.
It might be that's like a basic question for understanding your methodology, but what
Mhm.
exactly is a model supposed to be and how is it represented? Is it represented via requirements, via how do you visualize? How can I visualize a model?
Okay. Okay. So yeah, it's we'll cover this one. Basically, a model is a data structure for a computer. Okay. It we'll have some visualization data, but it's basically a graph. It's like it goes. You start here and you go. Maybe you're modeling a user journey, and so the user logs in, and then they get to the dashboard, and then they choose their profile, and then they do stuff like that. So it's kind of like looks like flows if you model user actions, right? If you're modeling, you can model, I don't know, a rover, for example. We had some client that had a roving bot, right? And we had to model what it's, the state it's going to, if it's like goes out of battery, about to go out of battery, then it needs to have one set of actions. And if it's actually getting some, it's vacuuming currently or something that and goes out of battery. So there's all kind of combinations. But at the end of the day, it's a graph. Okay, it's a set of states that program can be in. And we'll see some examples soon. So the promise is, to summarize, the promise is this. First of all, we get the test scenario generation and maintenance automated. We have automated test suite composition and maintenance again. Because of all the metadata that we generate, we actually know what's the functional coverage. That we know what it means that all the tests have passed. We become much more agile as far as QA because the work we do, the maintenance we do is basically proportional to changes rather to scenario counts, which is what you need for being agile. There's a good communication, and we'll see this in the next slide. And also a lot of validation, verification, and stuff like that. So basically, it allows QA to deliver faster and earlier, deliver more value faster and earlier in the software development lifecycle, which is, I think, all in all good. So the idea of model-based testing is not necessarily, I mean, it's not new. The first one to do this, to pull this off, was Larry Effelbaum in 1997. And he did it for testing a telephone switchboard. And what you see here is this an example of one model, one type of model. This is known as a state machine. And basically, any test scenario starts at the entry, and then we go to this state, and then people can maybe read it back to me, go to read it back to me and come back, or in caller recording and come back, and all kind of states, and eventually they end up hanging finishing the call. Basically, this is the any traversal on this state machine going on the arrows basically generates a test case. And this is a very efficient way of creating tests. And it worked well for Larry and Teradyne, the company that created the switchboards. And from there, other companies did similar things. There's GraphWalker, which is actually still alive today, the open source library. Intel had a similar thing based on code called FMBT. Microsoft had something called Spec Explorer. I think it's, I'm not sure it's still alive. And then there's us. And there are some other libraries as well out there, generating basically this kind of idea. So there are many tools for doing it. So let's look at one example. Okay, I'm going to take a somewhat silly example, but it allows me to highlight what all the points we need here. And this is it. Okay, so suppose this is the PID. We have a morning routine. Okay, the kid going to kindergarten in the morning. You can imagine what type of morning I had before I came up with this example, right? But basically, we need to take the kid into the kindergarten, and before that, we need to wake them up, put their clothes on, brush teeth, tidy up, and go out. This is the basic idea. So to do this, this is one example of modeling. We basically do this kind of scenario, right? So we tell the kid to wake up, and then at any order, because there's no order specified about the clothes. So we can just say, okay, we're going to test all the possible orders for this. And then the kid then dress up, brush teeth, tidy up, and go out. So this is one way of specifying a model. Obviously, simple enough for online meetup. But there are other ways. Obviously, we can create these flow charts. There's some. I mean, this specific is a screenshot from a insurance company where there's a lot of insurance parameters for insurance claim. If you've done QA for insurance, probably. There's like huge amount of options which make more sense to just do it in a table. And BPMN is also used sometimes. But the basic idea is the same, right? We set up this kind of scenario, and from there we can actually draw this. So this is automatically drawn from the code we've seen before. Okay, so it actually gives you hard feedback of what's about to be tested. Again, there's no system implementation yet, and already we can see that any of those errors is one possible test scenario, right? In this case, we wake up, then we wear socks, wear pants, shoes, shirt, and then go out. And there's another scenario where we do stuff in a different order. Okay, so this is already part of something you can take to product or even to the stakeholder that asked the product, the customer, and tell them this is what's about to happen. Is this okay? And I've seen cases where this just being able to say, this is what we're about to test would make the product say, well, this is actually this error, this doesn't make sense here. That was just the same insurance company. So the product goes like, why do you test this error here? And the QA woman using her product, she was like, yeah, well, you told me to. It's in the PRD. And the product goes, no, it's not. And they went back to the PRD, and it was actually ambiguous. So she had a valid understanding of the PRD, but it was not what the product intended. So they actually updated the PRD. Okay, so this is one way of communicating out. Now, already in this decision, maybe you get like a letter from the kindergarten teacher telling you that under no circumstances except for when explicitly instructed to do blah, 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 and you take this to your friend who studied the law, and he tells you, well, basically what it means that don't send the kids with the socks over the shoes, which is actually turns out to be an option. So instead of like going back and fixing it, we can just add a piece of code that forbids this from happening. Or saying, if someone wear shoes and then wear socks, then this shouldn't be allowed. We shouldn't have this type of scenario even present. And the system would actually get this. So not only it will tell us that this is happening, it also tells us how to get to this kind of violation. Again, this is completely automated. And so the question, whose bug is this, right? Who suppose, this is happening, right? Maybe it's like in a banking application, you were expecting a scenario where someone transfer funds to an unapproved account because we're testing some feature of a quick transfer, and somebody forgot to put the test in. So this is a type of bug that's actually for the product, right? This is because there's no application involved here yet. We'll put automation in, we'll put everything, but currently this is just the requirements checked against regulations, basically, right? No socks after shoes. And we're able to find bugs in the requirements before any implementation is done. Okay, so this is again QA moving way left, making sure that the requirements are correct even before the system is starting to get implemented. And then, right, suppose the system is actually implemented at some point, or in this case, we have this child simulator in case you want to dress virtual kids up. I can give you the link. Once we have that ready, all we need to do is just add automation code. Again, this is I'm not looking at the specific product. The point is that we can basically weave in automation instructions into the model, and once it's weaved in, we can actually run the systems, and you can say that it's automated straight from the model. Okay, so this is an easy. I'm sure you've all seen automations before, but this is it doesn't end just with the graphs. Okay, we can actually automate things from models. We can also export the scenarios to third party, like generate Python code or TypeScript code out of a test scenario, automatically generate manual test books. So the main idea for the model is not how you automate things. It's more about the fact that you're able to create a test scenario automatically and to compose a test suite, which is what we'll look at next. And the actual automation is, depending on the product, it can be either exported to a third party or done internally. So let's look at the test suite composition, unless there's any questions on it. I don't see anything in the chat. So, okay, so let's go on. So I've added, this is the model we had before on the left, and we've added some breakfast options on the right just to make it more kind of like meaty or something along those lines, right? So we have a lot of tests, a lot of possible tests. Anytime we go from start to here is basically a test scenario. So the question is, okay, we have quite a few tests here, and we don't want to run everything. We want to just create a good enough test suite that covers what we want to cover. So this is one example, right? We give it the goal of eating banana, eating salad, eating cereal, and eating a healthy breakfast, which are, by the way, not mutually exclusive, right? The banana is part of a healthy breakfast. So we don't need to have a test scenario per goal. We can actually optimize over this. And we also wanted one option for skipping breakfast. And we told it to cover it in 5 tests, and actually it was able to do this. Okay, so we have 5 test scenarios here. We can actually, normally, you don't always have to be able to see them, but here you can. So we have someone that goes here, something that goes here through this, I think, basic breakfast, and eating salad and cheese and egg. And this is another test scenario, and finally we have 2 test scenarios that go here. Right, so it's 5 test scenarios, and we cover all the goals we wanted. This, by the way, is an interesting example of what it means to have a model for all possible tests, right? Because you can actually see all tests that could be done, and you can see tests that you're about to do. And when these meetings where you have to approve the test plan, test readiness reviews, this kind of thing, normally just go over a long Excel or long list of scenarios. You put one of these graphics on, and you can actually see, people can interact with it, say, okay, how come you're not checking this? I want to check what happens if you eat egg after someone ate cheese, for example, or one of these things. So you can actually cover very well communicate very well what you're about to test. Another composition, suppose someone has, say, I think bad things happen when you wear a shirt last. Right, so again, this is the same test model, but now it's optimized for a different set of tools. Again, 5 test scenarios. And you can see that all test scenarios, we don't really care much about the breakfast. We have to do it because we need to finalize the flow. But what we care about is the fact that we wear shirt last. And this is what's happening here, right? So there's all the test scenario pass through shirt last, and we have and so we're able to view this or to check our thesis about what happens when you wear shirt last. Okay, so generally speaking, this is model-based testing. Use cases are test scenarios. Obviously, that's the first thing that comes to mind. It's also what we've seen now. The idea of parameter space exploration. What you see on the right here is actually another model for an insurance claim, API for insurance claims. So there's no scenario here. It's basically the actual test is sending an API request and getting a rejected or accepted or go see a human response. So there's no scenario, but what we do have is a lot of parameter combinations. And that's another thing you can do. You don't have to model specific user behavior. You can model a space of parameters, stuff like that. We see a lot of, well, not a lot, not enough at least, model-based testing in certification, user acceptance tests, these kind of things, because these type of activities actually require us to, it's not enough that all the tests pass, right? We need to make sure that the test actually shows something, we prove something, the test cover all or cover enough options or enough combinations or specific combinations that are considered high risk, and we want to make sure that at least these are working. So using these kind of things. Software archaeology. This actually happened to me. And so the idea is normally we start with the requirements and then we go from there. But sometimes you're working on an old system that doesn't have requirements or had requirements 30 years ago. And so we were working with a client and they had like a mainframe with 30 years of logic and nobody was really sure what's happening. Nobody had the whole picture. A lot of people in the organizations had like new parts of the system. So what we did was basically create this type of visualization. And I'd give it to one of the interns there, and she would go and visit the correct specialists for each part, and they would fix it. And so we ended up having this type of model which kind of like had all the knowledge, organizational knowledge, and we could later use it to create tests. So it's basically kind of like gives you an active documentation, right? If the graph is wrong, the test don't pass. Or if the system, diverges from the graph, which again is the model we're using for creating the tests automatically, then again, the build breaks. And we can also use this for algorithm verification, checking this kind of thing, just checking the model itself. We should probably not use model-based testing first of all, exploratory testing is, that's the classic, it's almost inverse of model-based testing. It's the idea, model-based testing expects to know what's about to happen, and with exploratory, you just go in, start playing with stuff. Sometimes, being a new approach, it's a lot of people find it interesting, but also it takes some learning curve and some adaptation. Sometimes it's just resistance to change. People say, I like what I do. I don't like to put new tools, or we have enough on our plate anyway. And sometimes we just try one model. It doesn't really fit the problem because we thought the problem would be like easily model using one way of doing it. One of the tables we've seen, for example, it's actually more of a state machine or more of a scenario composition or stuff like that. So, if it doesn't work for the first time, maybe it's not a good fit, but maybe also kind of like backtrack and try again. So in summary, basically, model-based testing gives us automated test scenario generation and test suite generation, optimization. Allows us to stop babysitting scenarios and start and focus on the intended application or feature behavior and to deliver value earlier. It works very well with Gen AI in the sense that when an agent or cursor or coding assistant, copilot, whatever, when it generates a model, because a model is something you can visualize, it's much easier to understand what the model did, what the AI did. So unlike when you use AI to generate code and then just hope that some test or unit test or something would find errors, here you can actually understand what the model, what the AI did, or what the AI understood from what you told it. Right? So the same way you'd use your model to communicate with the product and with the other stakeholders, even non-technical ones, you basically use the same mechanism so you understand what's happening or what's about to happen based on what the Gen AI did. It shifts QA way like left test, I'd say, in a way, right? Because we can start giving hard value from once the requirements are ready, working with the product and finding bugs for the product before implementation happens, and also clarifying requirements. I mean, finding bugs with the product is maybe a bit of an extreme case, but just making sure you sit with the product, say this is what about to happen, being able to ask questions that would make the product clarify what they're about to ask from the team. Does a lot of good for the software development process. Having said that, it doesn't solve everything, right? So as I said, not exploratory testing, takes some learning, it's not like you sprinkle it on top of your process and everything just goes amazing. So if you're interested in learning more, there's all kind of resources. By the way, the model to the left here is our own test.
So there was a question from Clary. Which industries are adopting model-based testing right now? Do you think MBT is especially beneficial for certain industries?
Which are those? So it's been we've seen it a lot in obviously medical, defense, these kind of things. I wouldn't say it's being adopted a lot. We're trying to push adoption, okay? But I've seen it being adopted successfully in medical, in defense. There are cases where you can't mess things up. In medical specifically, you also need all this certification, right? Or authority to operate processes. So you need to prove to the FDA or to some authority that you've done proper testing, right? And it needs to be like you have to prove due process. So model-based testing is a natural fit for that kind of thing. Cases where you have regulations like banking, insurance, these kind of things, and infrastructure. So if you have like digital, something where a bug would cost you a lot. Like if infrastructure controlling for a data center, for example, Cloudflare kind of thing, where each second of outage costs you a lot. Then people would spend more time in testing and would like to enjoy this added certainty and robustness.
Cool. And we have a question from Noel. If there is a back or previous button, how does it deal with the infinite graph? Since one can go back and forth infinitely.
Oh, great question. So two things. First of all, it's the generated scenario is generated. Okay, I'm going two options here. So some tools just drive it. So if there's an infinite graph, you do infinite execution. I've done that for a model satellite where we had to chase memory leak. Right. So in this case, you need to just drive a very long scenario and check the memory usage graph. If you just generate test scenarios, normally you just generate them you generate finite ones, right? Otherwise, it wouldn't end. And you can just limit the amount of time you can click the back button or go to a central place.
All right. All right. So we had one more question. Let's see. We had a question about the GitHub. I use GitHub Copilot for generating test cases based on the feature description acceptance criteria providing MD files. Model seems similar to the info I provide in these files. I like the concept of the algorithm-based model description. Do you know how we can incorporate this algorithm format specification in the MD files?
So you can probably just use put these MD files in like in Copilot chat and have them generate our kind of models. I mean, we do this kind of thing for us. Again, I'm not sure what other people are doing in this area. But for us, if you open GitHub, not GitHub, VS Code with GitHub Copilot, you normally can just paste the description on one side and you'd get a model, and then you can start working on the model. And then again, you get the added benefit of describing. Normally, this type of descriptions are more, I mean, if you describe behavior rather than a specific script, you get a lot of tests, and you can a lot of test scenarios you can derive from.
Samir, does that help? Does that answer your question? Right, maybe Samir is not able to speak up. And like I am curious too, like my question is similar to this. Can we use AI to generate the model for us? Or is the model should be a human kind of, activity?
Yes, you can tell AI to generate a model, and then you can normally, I mean, this is what normally I do is tell it to generate a beginning of the model, visualize it, understand what's happening, and then either tweak it directly or tweak it through chat again. But it's something that works very well with Gen AI.
Yeah, I think that's a great approach. Do you have any tools, AI tools that you recommend for generating models?
I normally, again, this is specific to our product, right? So we have a VS Code plugin, and we just use, you get very good results just using like Sonnet or basic ChatGPT kind of thing.
All right. Do we have any last questions? We have like a few minutes if anyone wants to ask any other questions. Okay. Sami is asking that the model sample you showed, is that how you specify your models?
No, so we specify model using a few things. One is code, but again, it's like basic JavaScript. The other one is all kind of diagrams. We had two screenshots there, BPMN and some sort of flow, Node-RED kind of thing, and also tables, so parameter tables. And you basically just compile everything to one big model. So if there's one aspect that's easier for you to describe in a table, then you'd use this table. And if there's some other aspect I mean, normally you'd have like the test case parameters in a table, and then the user flow in some graph, and then the automation in code. And they're all like compiled to the same thing.
Great. Amazing. Samia, great questions. I sometimes have prizes for people with the great questions, at least in the in-person meetups. But today it's virtual, so sorry, no prizes, but we give you a virtual prize for the great questions.
Yeah,
All right, folks, that's an hour. We're at the end of the hour now. Want to thank you, Michael, for sharing your expertise and knowledge with us.
Oh,
This
thank
sounds
you.
like a really great approach to testing. With the help of the AI, we can make it now efficient. I bet people had a hard time creating the models because it's time consuming, but with AI right now, it's doable. So I can see how this approach might, become even more popular.
Yeah, I hope. And you have my contact. So if you want to delve into this world, I'm happy to help.
Yes, folks, Michael shared his contact. I'm happy to share my LinkedIn. Feel free to connect with us. We would love to stay in touch. Feel free to share your LinkedIns if you're still here. We'll do more of the networking next time. But feel free to connect on LinkedIn with both of us. All right. Thank you, everyone. See you next time.